All right, here's a couple of questions of understanding solutions and molarity. It says I have two solutions of sodium chloride. One's 2 moles per 2.0 molar, which means 2.00 moles in every liter. So let's just say this is 1 liter. So that would mean I have 2 moles. Now, there'd be a whole lot more than this, but I'm just going to put 2 dots to represent the 2 moles. And then it says I have much more of the 5 molar solution. So I made a bigger tank there. And why don't we say, I don't know, why don't we call this 4 liters? Okay, so if I have 4 liters, I'm just going to, there's 1, 2, 3, 4. Okay, and in each liter, there's 5 moles, right? That's what this means, 5 moles per liter. So 1, 2, 3, 4, 5, 2, 3, 4, 5, 3, 4, 5, 2, 3, 4, 5. Okay. Then they say, which of the following could be the concentration if they put them together? They add them together. So watch when I add this together. Just a second. I need to group that. So if I add this together to this one and dump it in there, take a look that there's lots more liquid in here, lots more liquid to add to the total container. So now I'm looking at that whole container. So there's a lot more liquid and not very many moles of sodium chloride to add to the mix. Then the total concentration, as these here sort of start filtering this way and looking for more room to wander, then there's more room for each one of these moles to be in. In other words, the concentration has to go down. So they say I've got lots more of this stuff. So I just have this, the concentration will decrease just a little bit because I guess there's quite a bit less of this than there is of this. So the concentration will go down a little bit, but not a ton. So if it started at 5, then I'd probably say 4.6, 3.5. I don't think that's gone down nearly enough. If it was opposite, so say in the small thing, I had a real high concentration of things, and in the big one, it wasn't very concentrated. When you put these together, notice that there's lots more room for all these things to wander around, and so the concentration of this stuff would go way down, or of this stuff, it would just go up by a little bit, because these things here would have lots of room. At any rate, with this question that we had, I would pick that number, that the concentration would go down a little bit because of the extra water or the extra solvent that was added to it, but the concentration wouldn't go down that much. It wouldn't go up. It can't go up because you're adding a volume of water, so you're adding extra water to that, so that's diluting the container. Yes, you do have a few of these, but in comparison, their concentration is way less than it was here. All right, and it's very similar to that one. It says I have 2 HCl solutions, A and B, and I'm just using these top 2 for now. I might use the bottom ones later. And it says solution A has a greater concentration than B. So why don't we just put some dots in there? I think that's 10. And B, let's put 5 in. Okay? So concentration of A is greater than B. Which of the following is true? To obtain equal concentrations of both solutions, you must add water to B. Okay, if I were to add, let's do red for this one. So if I were to add water to this, what would its concentration of this do? Hopefully it said it would go down. So if I'm wanting these two to be equal, if I add water to this, this concentration is not going to match this one over on A. If I have more water there, the concentration of B is going to go down even further. So that's not true. If I add more moles of HCl to both solutions, they'll make them less concentrated. So if I add more moles to each one without changing how much liquid is in there, they say that's going to make them less concentrated? No, that's not true. Okay, if I have equal moles of HCl in both solutions, solution B must have a greater volume. Let's say equal moles. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So they have equal moles in each side. But up above here, they said the concentration of A was greater than the concentration of B. So if they have the same volume, the concentrations would be the same. So in order for the concentration of B to be smaller, I'd need a bigger container. So if I had a bigger container, then the concentration would be less. And so this one here, I think, would be true. Then there's a couple others. If you have equal volumes of both solutions, solution B must contain more moles. That's exact opposite. So if I have equal volume, let me make these equal volume again. So if they're equal volume, they say B must contain more moles. It can't contain more moles because B is less concentrated. This one's less concentrated, so if it has more moles, it would be a higher concentration. If they were the same volume, for this statement up here to be true, then I'd have to have fewer moles in here. Where's my eraser? Fewer moles in here. So if the volumes are the same, in order for B to be less concentrated, I'd need less moles. And here they say more moles. That's not right. And then last, at least 2 of the statements above are true. No, I just see one true. Just that one. Hopefully that helps you understand that a little bit better.